Um, Daniel, just so we know, we have a couple other Dgraph attendees that we'll want to bring in as well.
Sounds good.
Abhimanyu is one of them. And let me see here. Who else we got? Naman as well. As they come in, we might want to let them in as co-hosts. Let me just ping them and see.
Sounds good. I appreciate everybody taking the time over the next hour to hang out with us here. I have purposely told Matt he's not allowed to prepare for this. We're never allowed to prepare for these talks because we don't want anything to look polished or put together. We want to experience these things the same way anybody else does the first time they kind of look at them, right? That's kind of the idea. Though we do have some experience with the technology, so I would hope that that can help and guide us forward. But we've got some other engineers around too from Dgraph that can help us if we really get stuck, which is quite possible. Do we have those other people that you want in? Can we start kind of having this conversation?
Yep. Abhimanyu is going to be rejoining as a panelist. So he should pop up here shortly.
All right.
And is Naman, has he joined yet? I'm not sure if he has. Cool. Yeah, Abhimanyu is going to join us. He is, pretty versed in GraphQL and graph databases, and hoping maybe he'll have some insight for us for our SQL conversion here too, if we do get stuck. So
this is good. I'm excited because I've done some of this data modeling, and I think I have a good foundation, but there's always something that comes up that I just don't know how to deal with. So having people around is fantastic.
Yeah, and this is something that, this type of exercise has been something that I wouldn't say struggled with, but definitely wrestled with over the last few years, especially just going from SQL to any type of NoSQL, whether you're going to a graph database or whether you're going to a document-based database, something like more along the lines of MongoDB. It is a skill that I think is learned over time, and you get a little more comfortable with it.
Yeah. So let's see how well we do today. I'm setting up my laptop here a little bit so we can at least have a couple of screens. I also going to have to bring up a project that I have to remind me of some of the syntax because I don't remember everything off the top of my head. I've been doing a lot with Ghost services lately and trying to get back to more Dgraph stuff. All right, so let's do the following. Actually, I'm going to do this one more thing, and then I'm going to share my screen, and we'll get some things going here. Let me share my screen here since I'm the one who's apparently going to be driving today. Let's see what we got. Okay, cool. I was just kind of setting this up a little bit more. So what we're going to have is on the left here, I've got a schema that I would say about 15 minutes ago we found on the internet. Matt's laughing. It's like, oh my God, I can't believe we're doing this. Well, this is real life, man. Some client comes in, they're like, come on, we gotta help. And you sit down and it's the first time you're kind of looking at it. So this is going to be the schema that we're going to be playing with today. We really have not looked at it or studied it. So we're going to have to spend a little time studying it. But before we do, what I'm going to do is we're going to log into, at least my account here, into the Dgraph cloud environment. And one of the things I did just to always even have more fun, because why not, is I destroyed any sort of backend database I've been working on, and we're going to start completely from scratch just to see what's going on there. So when you log into Dgraph or you create one of these Dgraph cloud accounts like I have, you can see here that it's starting off with, let's get you started. I'm going to launch a new backend. A database here is called a backend. And you can see that you get one free one. You get one shared one here. The shared one is going to cost you like $10. You can see limited to 25 gig. That's fine. And then you got these dedicated ones. And this gives you things like access control lists, authentication, authorization, other stuff. And we'll talk about these things over the months to come. I'm really excited about the ACL and playing with the access control list there. But what we need right now is just a free one. So I'm going to select free. Since I'm in Miami, I'll pick the US East Coast. I don't have to do a name or anything like that. Or is this the name of my new back end? Like,
Yeah, you don't have to enter it. And I think this would allow you to, and Daniel would probably be able to get a thumbs up on whether this is true or not, but I think it'll generate a name or you can put a name in.
I think it gave me some name like pod or.
Yeah, it should give you.
There we go.
All right, let's just launch it and see what happens. This one, I called it Little Tree, it looks like. It comes with these cool little names. I think the other one was, I don't remember, Pond or something. All right, so our Little Tree free back end is up and going. And the reason I wanted to get our back end here, we got a database now that we can play with. We can go into this cool schema tool and we can start to kind of type out the schema that we think we need for this particular database. But maybe we should kind of look at this schema here first and get a general sense of how it's laid out. So I see, and maybe what I'll do, I just want to look at one thing here.
Bill, maybe it might be better for us to first kind of explain, because we do have a lot of, like, this is, I think everyone on here is a SQL user. So it'll be really, maybe they're not familiar with graph databases. So maybe it'd be important for us to kind of explain, you know, what's the shining part of a graph database. And if you want, I can go over that really quickly with my knowledge, or if you'd like to.
Yeah, no, why don't you do that?
Yeah, while you're plugging away. So I'm assuming that everyone that's joined this is, well, most developers are familiar with SQL. And some of us will probably be familiar with a document-based NoSQL instance. You know, maybe some of you used FireDB, like the on Firebase, so Firestore, stuff like that. Maybe you've used MongoDB. The nice, like they're great. They have a great amount of flexibility, but it's really tough to enforce relationships within those. And that's where, for me at least, that's where that graph database really kind of takes hold, because you get this flexibility that you get with document based, where, you know, we can change what our objects look like really, really easily. But with a graph database, we're also able to enforce relationships and establish relationships in the data that would normally have to be more manual if we're doing it through a traditional NoSQL database. And if we think about it from a SQL perspective, that's where we'd start to do stuff with foreign keys. We don't have any foreign keys in a graph database, which also means that querying is much easier because you don't have to do a bunch of joins. And maybe if we have time, we can, or if you're able to dig into it, you can see massive SQL queries can be boiled down usually into a single line with a graph database query. So with that said, Bill, I'll let you continue on.
Well, at this point, I am just kind of, while you were talking, kind of playing with the idea that we just kind of focus on the blue tables right now. I think there's a lot there to kind of talk about, right? And I see up there that we've got a customers table, and probably the first one that we'd want to start with putting together. So if you've never seen a GraphQL schema before, one of the things I like about it is that it looks and feels like code, right? And we see this here. Now, one of the questions that I'm always thinking about is this ID. You can see in this relational database, there's this customer ID, which is supposed to have that unique ID for every row of data in that customers. We could technically still have our own kind of customer ID if we want there. But one of the things that I've been doing with my GraphQL schemas is just using a field called ID to kind of represent that. I would almost argue that this schema has some, what we would call stutter in it, right? Like the table's already called customers, so why call that customer's ID? No, that would be, for me, kind of stuttering. It's been so long since I built a SQL schema from scratch that I don't even remember what I was doing 10 years ago with that. But from what I've seen here, ID. So I've kind of just blindly, without thinking about it too much, added the ID fields to these 4 types where right now, at least in my head, I've got these types that I'm considering that we're going to need. Maybe if I go a little, I'll stay big here. So for the 5 tables, at least right now, because I'm literally just working this off the top of my head with what I see. At least I'll lay that out. Now, when we make this an ID field, what we're basically doing is asking Dgraph to generate the unique ID for each kind of customer, order, staff, or stores that we add. Now, one of the things that's interesting to me, Matt, is I don't think of this as a table with a collection of rows. I think of this as a node of data. So I'm not sure I like the idea of using the plural names. I think it makes sense on the table side because you can think of that as a collection of customers, but I always think of our graph database as this like large space that just so happens to have nodes of data in it, that just so happen to have relationships, but nothing is really boxed in. Like, what are your thoughts on?
Yeah, I think when you think of it from that perspective, it makes sense. I mean, with my experience with Dgraph, I normally would still follow the convention of having the plural, but I do like your idea of having it singular. And the reason why is if you do look at it from, like if you use Rattle, which is a part of Dgraph that allows you to visualize that data, you can see that, yeah, it makes sense, Bill. The way that you're talking about it makes a lot more sense because it is an open space. Everything is connected differently. You don't see table layouts that are all joined together. So I do like this approach. Yeah, I think we should move forward with maybe the singular.
Yeah, because I think what's nice is the Dgraph has removed a layer of collection, right? Like it's not a table of rows, it's a database of nodes. So, all right, so I'm gonna keep that. Now let's go look at what's in customers. I don't think we have to add everything here for the time that we have, but there are some things that we should kind of talk about. So, oh, I've got 2 tabs there. Let's just do one. So first name, right? Now, here's something interesting, right? They're using underscores in the name. I'm going to refer back to this sometimes to see if I followed some of the same naming conventions in a project that I used. And maybe what you might also see me do is use this as reference because I don't remember everything. But it looks like I'm using that same sort of naming convention here. And I guess that follows the idea of JSON and GraphQL and stuff, using that kind of underscore naming convention instead of camel case or anything else. So we know this one first name is going to be a string. Now, this use of the exclamation point basically says that we can't have a node of type customer in the database unless that first name is absolutely there, right? It can't be null, in other words, or it can't be absent. Can't be absent. So we would definitely have the first name. We know the last name would kind of match with that. Phone number would be a string. Email would be a string. So kind of like the rest of those are strings here, right? So maybe I'll just do last name. And there's nothing else really kind of interesting, except let's think about this at this point with the customer. How would we want to maybe query a customer? With this diagram doesn't really show, it shows the foreign, the relationships that are going to be important, but it doesn't really show how we might want to query the data. And there's probably a good chance that if I'm going to look up a customer, I may want to look them up by last name, right? So it might be interesting to apply, at least right now for where we are. It might be, this is probably too early in the process, but since we're here, it might be interesting to just at least know that I'm going to want to look up somebody maybe by last name here. Though I'm interested in separating first name, last name. So when I go back to one of my other schemas here, I see these search things. Let's do that. I'll do this one for a second. So let me double check. Yeah, okay. So we've got this as search. And what that's going to do now is give me the ability to do a search on the last name of a customer. We'll always be able to search on the ID field. But now off the top of my head, and I don't have any documentation on this, there are different ways that we can do a search, right? In this particular case, I'm doing a search with an exact, which honestly is probably not the best way that we'd want to do that. We probably want to be able to search not matching the name exactly. I don't remember where we can find the information for the different searches. So Matt, maybe you can look that up while I'm going, and then we'll drop a link somewhere. But at least right now, we have some basic syntax to show how we can search by last name. All right, so let's just kind of keep that for now. We know the rest of the fields are going to be strings. We know we could lay them out, and we're kind of leveraging this naming convention with the underscore. Now, when I look at the orders table, it looks like there's a lot kind of going on with orders, right? It has its own ID, so that's fine. We add that. It also has a customer ID, which means that this order has a customer. Okay, so now that gets kind of interesting, right? Because we can see here that there's that relationship between the two tables with that ID. Now, I had the same sort of situation with that travel project that I've been working on. And I had it with this idea of a city having an advisory, a city having an advisory. And we can see here on this schema that I played with, what I did is we didn't do this necessarily by ID, but we did it by that type, right? So even if I just copy this for a second and it's not necessarily a city here, for me, the idea would be then that I'd want a customer and an order would have a customer. And this is how we would kind of create that relationship between an order having a customer. And when we form the queries right, we don't necessarily have to duplicate a customer for every order that uses the same customer. We can create that edge or that link between the two.
Yeah, the order table is going to be the hardest one for us to move over because it's a junction table. So I think for those who are watching, if you're going to pay attention to any part that we're going to do right now, this is probably the most crucial because we have the most relationships within this orders table that we're transferring over right now.
Right. Okay, so what we're doing now is saying that this order is bound by this customer, but it might be interesting at a customer level to see all the orders that a customer has, right? And because we're dealing with graphs, I think we're able to do something like that, right? Like if I go back and I look at this, I'm gonna steal this for a second. My brain doesn't have things memorized, but my brain is thinking that would it make sense? Is this how we would do it? Where we're saying a customer does have a set of orders. It's a collection of orders, has inverse. The field is, the field then is, let me double check what I did here. The field is city because the city matched the city in there. So is that customer here then? And that gives us the,
I think would it be ID?
let's think about that again, because we want to create this reverse relationship where we're talking about a customer, this particular customer here.
Yeah.
Oh, this has to be probably of the right type. Let me double check that. Oh no, lowercase city matching the field city has inverse in a place. So if we're saying here orders, plural, I'm trying to bind it to the customer field. So I don't know, expected type string not found. That I don't understand why we're getting that little message, but I'm going to just keep going with it. So this is what I'm thinking here. This gives us that kind of reverse relationship. All of this can be linked with those edges on these IDs, right? And I think what happens is when we construct this order, if it's with this same customer, we'll do that with the mutation, then all of this should kind of get linked together. And we'll have now the relationship where from a customer, we can get to all the orders. And then from an order, we can get back to the customer's state. So I think this is what we want to do. I don't know if Daniel or anyone else on the call wants to inject a little bit here. Am I way off? Am I right? Why is our schema tool giving me problems here? Is it because we haven't saved this or deployed it? I don't know if anybody wants to chime in. If not, I'm going to assume I'm good.
Naman, Abhimanyu, any feedback for us?
Yeah, I guess maybe you can put it as a string.
Put it as
The field has inverse has an argument called field. Maybe the customer should be put as a string there. I mean, within double quotes.
so. Would that mean that maybe we would use orders? So
Yeah,
Bill, what is
put double quotes around it. Yeah, put double quotes around it.
Oh, right.
Like that.
Yeah, yeah.
Why
Yeah,
didn't I have to do that on my schema that I've been using for this travel project that I've been working on? Is it just because it's a UI kind of issue?
It could be.
Okay.
Keyword
Let's-
errors. Yeah, but like GraphQL allows you input coercion, so that was previously acting as an enumeration.
Okay. Now, do you like what I did here to create the inverse relationship? So when I do have a customer, I can see all the orders and we make sure our mutations are done right. Is this how you would recommend to create this relationship that you're seeing here between, say, customers and orders? This is how I've done it.
Yeah. This looks good. Yeah.
Nice.
Yeah, this is how I would do it as well, Bill.
This is what I love about the GraphQL, right? Like I've built these two relationships against these types, and this data can float in space in a sense, but it's these edges, these relationships that are going to get us to this data quickly.
Yeah,
Okay.
and then it really comes out once we look at the data visualizer and see how we can kind of sort through all the stuff. I think that really shows the power of the minimal amount of stuff we need to do here to get these relationships going.
Yeah. So let's do the following then. Let's take a look at orders a little bit more. We've got the customer relationship. I still feel like there's stuttering in this schema, right? Like, I think I'd rather just have a status here. Now, again, I don't know what the status field is, but let's say that maybe what they're doing is the status is maybe an int, right? Or how do we do this? That int or integer? I don't remember here. Let's see if I have anything in original. No, it is int. Okay. Oh, I forgot my colon. So it's an int. And then since it's an integer, maybe this gets interesting, right? Let's add some enums here. So the idea here then would be maybe we have some statuses, right? Like, I don't know. I'm just going to pretend to create some. No, wait. Oh, but if it's an enum, then it's not going to be of int, right? I'm thinking Go right now. This would then be of type status, wouldn't it? And we can have maybe open, closed. What do you think about that?
Bill, this is something that I've always kind of debated on when it comes to NoSQL data modeling, because sometimes what you have to do is when we think about SQL, we obviously think about these lookup tables. We have an ID value that correlates to some type of maybe a string status. Sometimes what you'll have in something like this would actually be, just instead of a status being a status, you might also just do a string in there of open or closed, and then handle it at the, beyond the backend, make sure that the consumers are doing it correctly, or build it into your service to make sure that it fits one of these two strings. So I'd love to see what you're going to do here with the enum stuff, because I know that I have a little bit of a different solution, but I'm not saying that it's better. It's probably actually worse.
What it is, like, we don't know, right?
Yeah.
Because we're prototyping right now. Let's be real. This is our first draft. Now,
Yeah.
if I had to truly keep the data model exactly the same, and that was an int, I would have to make this an int. Or if
Yeah.
it was a string, I would make it a string, right? If I have flexibility to take advantage of some things like enums here, it might be fun. So I don't think there's a right or a wrong answer. I think a lot of it's going to have to do with, what we love to say as engineers, it depends.
Yeah.
Right? So there's an engineering decision to be made here, and maybe this is something that we prototype. I'm going to leave it like this just to have some fun with the ecums.
Yeah, cool.
The other thing I'll just take from order here is the date, because I never remember what that date thing is. I don't know if I used any dates in my original. Oh, I did. Date time. There it is. Date time. So we can use date time. Oh, look at that. It even came up, which is nice. So we've got the date time there. Now, the problem here is, and I don't know, right? We wouldn't know until we wrote some code to do migrations. I don't remember what kind of date time format GraphQL is using as opposed to our SQL server. There's probably some marshaling that goes on somewhere between the two for moving data as opposed to just starting new. But we have that. Now, we don't have to add another date to that, but you can also see that there's relationships between store ID and staff ID, right? So what's interesting, what's interesting here when I'm looking at this SQL schema, I assumed that a customer has multiple orders, and I guess we can assume that an order can be processed by multiple stores and multiple staff, right? Like I don't know what these symbols, I don't remember top of my head what any of these symbols mean, but as I'm playing it out, we're going to have that same sort of scenario. So maybe what I want to do is I want to move my staff up here for a second.
Yeah, so staff can have many orders, stores can have many orders. I think orders and order items are one-to-one relationship.
So it looks like the staff type is almost identical to our customer in a sense. It had email, phone, active store ID, had a store manager. Let's go back to that. Well, we're focusing right now on orders and staff. So
yeah,
the question then is, we're going to have a staff, right? So an order is going to have a staff. So we're going to have this again. An order will have a staff. You know what gets interesting to me? And this one I would love to talk to Daniel or somebody on the team about. And this is totally me, I think, over optimizing things in my head. Sometimes you get too old and you have baggage. Like, what do you think is the best order for putting these fields together right now? Does it make sense to kind of keep everything in alphabetical order, which I've done at times, just because if I do alphabetical ordering, I don't have to think about anything else other than that, things are in order, which would mean that we would put here and A, B, C, D, right? So sometimes I like to just say, if we can keep an alphabetical order, then we're basically saying there is no necessarily order and everything can stay. Consistency is everything. But I think when I code in Go a lot, I have in my brain this idea of larger things kind of being on top of things, or maybe in this case, since these are types like customer and status as opposed to, or like customer and staff as opposed to a scalar type, to maybe keep all those things together. I don't know. I'm going to imagine that underneath the covers, Dgraph couldn't care less what we're doing here. So I don't know. What are your thoughts?
It's I think it's another one of those it depends, because so the way that I think exactly aligns with how this SQL schema is set up, where we have the ID at the top, and then what's the first thing I think of when I think about a customer? First name, last name, and kind of in order of importance, I move those things down. The less important things I might put at the bottom. So yeah, I will say I've never put things in alphabetical order, but I don't see a problem with that either, because when you do have, especially when you think about how this is laid out in this format, where you have basically a JSON-like object that you're creating this type within. It is nice if, let's just say, you have 100 different fields within that. Well, it is kind of nice to be able to go alphabetically and know, because everyone's rank of importance might be different. So maybe it depends on how big your objects are. That could be.
You know what I'm going to do? So we don't have to have the debate. I'm going to keep everything in alphabetical order as we can.
Okay.
I do like the idea of order of what we consider important. I would expect the team to do that. But yeah, I think if there's a lot of fields, that gets messed up. And then would you consider staff being more important than status or staff more important than date time? Like, I don't even know. And I just don't want to be paralyzed
Yeah.
by that decision, right?
Yeah.
Sometimes just doing this alphabetically eliminates you being paralyzed by trying to figure out an importance of something.
I think you have more ability to analyze this than I do. Normally I am in such a scramble to get tables together that I'm just doing whatever I possibly can to type it out quickly.
I think about, I'm always so focused on the average person on my team being able to read and comprehend this code.
Yep.
And sometimes I might be pre-optimizing that a little bit up front, but my brain is working through it. Okay, so I added the staff type, ID, first name, last name. We added a staff to the order. The question is, do we want to, at the staff level, also see all of the orders that a particular staff has been involved with, right?
We might want to, if we're pulling a report here, let's say we're pulling a report for staff, you know, we might want to grab that. I don't know. Abhimanyu, Naman, any thoughts on that about, you know, should we think ahead of maybe how we're going to be reporting stuff? Does it make sense to have, you know, orders in multiple places, or can we just use the staff and that within, as long as we have everything linked within orders, kind of like how we have this union table, this junction table. Does it make more sense to do that, or should we basically put a link to each of these types within every single type that might use it, or that we might be related to it?
Okay, so basically, like right now we are adding each type inside the order. So that would allow us to traverse to that type from an order. And if we want to do that, if we want to do only that thing, then it's fine. But let's say if I also want to go to an order, like basically I also want to find the orders that are served by a store, then I might want to travel to an order from a store. In that case, I would need an order inside the store. So
Okay.
it depends on how you want to traverse.
Okay. So it does depend on how we're going to use the data, how we would model it in a sense.
Yeah.
Okay.
So let's do this because we're half an hour in. Let's, I think if we start talking about order items, we're going to have the same sort of relationships we have already at this point, right? And so I think what becomes important here.
And what we can also do, Bill, is if we get stuff in there, and then when we go to the data visualizer and we see how it links up, we might go, oh, we can't traverse the way that we thought. We can go in here and edit it.
Yeah. So this is what I want to do right now. I want to, I'm going to knock this down one level so I can see. Hopefully everybody can still see. Let's deploy this schema to start. So we've got a customer, we've got some staff, we have orders that we're adding in the system, and let's try to do that. We'll add, let's deploy. Let's start with deploy this.
Okay. All right. Just like, and it's important to note, if you haven't used Dgraph before, that at this point, we now have a full backend ready to use. We have a GraphDB that has this schema loaded in, ready to go. And then we also have a front end ready GraphQL API that if we had a UI that wanted to use it, they could use it right now, just that one step.
Okay, so what we need to do right now is let's add a customer and let's add staff.
Yep.
Right? I did not make the collection of orders for a customer or staff mandatory, which is good because I want to get them in the system first. And then I want to start adding orders, and we should see that they show up automatically for those customers and that staff, right?
Should.
So let's see if we can pull that off. Now, my Zoom is here. Okay, so I want to switch to mutation down here, right? And hit add, and this will let me create a mutation. Okay, perfect. We can see, you think this is large enough? Or go a little larger.
There we go. Yep.
We want to add I said we're going to add a customer first. No, what I love about this tooling, again, we played with it last time, but now we're going to play for it for real. is it lets us kind of build the GraphQL we need kind of manual here, right? So let's say that the customer is me, William Kennedy. We're not going to have any orders yet. That's really all we need, right? Because of the fields, the ID field. So maybe I'll just kind of do this so I can see a little bit better. So here's my mutation. Now, I can't remember off the top of my head.
You don't have to change that. No, you don't have to.
That's going to just be part of the response, right?
Yeah, you could, like, it does make it easier when you look at the history of the mutations you've ran to do that, but.
Right, I mean, I can do this, right? I can, for the output to be more consistent. I think that would work, right? So let me see something here. Okay, so data, so this didn't matter at all. This was just so we can name things. I see that in the tool.
Now, once you click history, then you'll be able to see it there if you do decide to go that way. Gotcha.
And then this did come in as an alias there. Okay, so it says num new IDs 1. Okay, brilliant. So it looks like this worked, right?
Yep.
Switch back over to query. Hold on. Zoom is in my way now, and it won't disappear. Oh, wait. Oops. Sorry. I got to hide Zoom here. Hide the panels. Okay. If I click here, oh, cool. That kind of came down.
Yep.
Right over there. All right. So if I want to get this, oh, what ID ended up being used? Do I have this in the data? I forgot to ask for the ID, didn't I? Okay.
Easiest way, you could pull all customers, or the way that I usually do it is if you right click on Data Studio and go open a new tab, it'll show the ID for that customer and just copy and grab it. And it allows us to show off the Data Studio stuff.
I did an exact search on last name. So
you'd be able to get it.
Our search works for last name. So we're going to get customer. We should be able to. Now, why is this not doing what I'm expecting it to do? Oh, because get works with that. I have to query a customer.
Yeah.
Query a customer. All right. We're going to query.
And then under filter, if you drop it down.
All right. So I want all of that. Under filter, last name equals, oh, did I use capital letters? I don't know. We're going to find out. So let's take a look at this again. I love how this just builds it out. So we're going to filter last name equals Kennedy. I can do that because I added the index. Last name, ID, first name. If I run that, what do we got here? We've got the data that I wanted, right?
Bill, I want to show you something too while you're here, something that I found out a little while ago. So if you're using like Apollo Client or something like that, if you go to Code Exporter and you click on Code Exporter there, you can actually pull this stuff out. You can do like JavaScript fetch, or you can actually, if you click fetch and you go to Apollo, go over and go to React Apollo, you can take this, copy and paste it, and you already have the query ready to go.
That's brilliant.
In JavaScript, which is pretty cool.
Yeah, that's brilliant. Oh, I'm going to be playing with Apollo soon. So
yeah. So quick way to get your stuff exported into it is just use that.
So look at this ID. When I run Dgraph locally, they always have start with really small IDs. So now this is killing me that I can't select and paste this. What's going on here? I don't want to have to type that out. Well, that's a bummer. All right, we'll have to figure out what's going on with the UI there. So that customer absolutely got saved, and we can see the ID that is there. I really want to copy this thing, and I can't get to it. So I'm going to hack a little bit here. All right, maybe I don't need it. So let's go on.
You could paste it into the query editor as well and just quickly backspace the stuff that you wanted.
I do this all the time. Yeah, I guess I can do that.
If it works.
Yeah, we got to look at that. All right, so this is our customer ID, right? I'm just going to keep that here. If it stays around, great. Now what do we need to do? We need to add some staff, right? And this time I'm going to do this better.
Yeah.
Mutation. So add staff. We're going to use your name, your staff, right? Matt Tanner. And I want the ID back. So that should give me the ID back. That's what I want. I don't have to filter anything. So if I hit, oh,
And then do my mutation because it allows you to run multiples. Yeah.
oh, okay. And now we've got, and this works. So I wonder what was up with the other one. Can I get back to these different windows, or I should have been saving these IDs?
If you go to history, actually, if you go to history, you should see it there. If you run it, yeah. So that's why I was saying that if you actually name your queries and name your mutations, you can see them in the history, and then you can pull them up, and it'll restore what you had.
But I messed that up a little bit from before. Okay, that's fine. All right, so we now know that we have both a customer and some staff. The next part is adding an order, but to do this right, I need these IDs. So I have the staff ID, right? This is the staff ID. I think what I'm going to do, just to make my life easier right now with the
I believe you could also, and maybe the other guys will have to chime in. I believe you could run a query, save those IDs into a variable, and then run a mutation with those variables injected.
All right, well, before we do that, because of time, this is
There you go.
this is the staff ID. Let's just do this for now. This is the staff ID. That's your staff ID. Yeah, let me do that. Let's get back to.
So if you go back to if you want your customer one, in your history, if you go click on a couple of the ones closer to the top, when you bring it back up there.
Where do I look on the
So
top?
click history again. Click. Yeah. And then on the left pane there, right beside your query thing. Yeah. Click the ones at the top.
I didn't even see that.
Yeah. So if you click a little higher, you should be able to see it restore.
Yeah, it's right here.
Yeah, right there. So
I'm also running in a
that's
higher.
that's your staff ID there. That's your staff ID. But if you go to my query just above my mutation, you'll be able to get it.
Oh, that's the staff ID. I have to run it.
Well, there you go. Well, you added another customer now.
I added another customer. I am just not having fun here. I'm moving too fast and making mistakes. That's on me. Ooh, so now I've got 2 customers. Okay.
That's okay. That's all right. Not the end of the world for us.
No, it's not the end of the world.
We can always drop them after.
Yeah, or we're going to do that anyway. Let me get back to query. I got to get my head wrapped around this. So I don't know which query I ran here. I see. Oh man,
the most recent ones at the top. Yeah.
That was the ad. This was the customer one.
Yeah.
Okay, now
there you go.
Why? Now I'm getting it. Okay. Now I'm getting it. Okay. So that's the staff. That's the customer ID. And now we've got 2 customers, but it doesn't matter. These are the IDs we're going to work with. So now we want to add an order, and we want to make sure the order is bound to these IDs. That was the whole point of the way we set everything up.
Yep.
So let me do a mutation and add, and we're down here. And I want to add an order. Okay, this is where things get fun. Let me clear history so we've got more room here. Okay. This already added. This is the new order mutation, right?
That's your new order mutation. Yeah.
All right. This just stayed in the window. Do I need to see that? Maybe not.
You can get rid of that.
Okay. Now, when I'm adding an order, the things we need, oh, look at this. The enums came in right in here. That's kind of cool. So it's going to be open. Oh, what do we do for date?
Okay, this is a question that I've had for a while that maybe the guys will be able to answer. If we're using SQL, we can use like datetime.now on most platforms. Is there any equivalent that we can do in Dgraph GraphQL where we can just have it so it stamps the current date? Is there a function or something that we could use?
So yeah, as of now, there is nothing like that. But there was a plan to basically add a directive which can do that sort of thing, so that we just give the directive the schema and it can make it work like the now function in SQL.
Okay,
But
is
yeah,
it,
as of now, there's nothing.
okay, so we'll have to put something in, that's fine.
What do I do for this date? Can I just
Maybe you
type
can use lambdas to achieve that functionality if you want to.
Okay, for right now, Bill, I think I would try to plug that in. Worst case, the mutation is going to fail.
try this?
Yeah, I would just try it like that and see.
Okay.
I mean, I usually do 01, I guess that would work. Anything under 12 on both will work. I'm not sure what date format we've got, so.
All right, so let's do this before we try that. I selected ID here. I want to see all this stuff here. So I'm going to hit enter here so we can look at this stuff here. All right, let's see if the editor breaks. So I want to make sure that we're using this customer, right? And I want to make sure we're using that staff. Oh, I see. So that one went in and did all that good stuff. So if we look at this, I just want to see it. So pretty cool, right? Because when we use the ID for that customer and for this staff, it should bind all those relationships up, at least right there. So I should be able to, let's get the order ID back. So this will give me the order ID back from the query. And now I've got this cool query. If I run this, we should have an order, right? Now, this failed because it didn't like our date time. So we have to use this format.
There we go. Yeah, copy and paste it right in. That's what I normally do.
Exactly what I'm doing. All right, we'll try it again.
Let's see.
Yay, we got an order here. Let's add our order.
Some questions. Bill, so we've got some questions from YouTube Live as well.
Oh, yeah.
They also want to see how to demo the delete mutation. So we'll touch on the delete mutations shortly here once we create this order. Maybe we'll do it on that customer that we created. We can show them how to do a delete.
Yeah, we need
and we
to
have
delete that bad customer.
Yeah, yeah.
So this is the cool part. Wait, if I go into in here, will I see our graph? No, because I did that in
GraphQL. If this was DQL, I think you probably would.
so I won't be able to use this to see relationship.
You'll be able to see in Rattle. I believe you'll be able to see it. I believe you should be able to see it in Rattle.
It's not coming up, right?
Might need to click Rattle again.
All right, let's try it again.
Yeah.
Oh, here we are.
There we go. All right. Cool. So we can see staff.
So what am I looking at here? I'm looking at the one staff node.
Yep.
I'm looking at I didn't expect to see this. Let me
Order. Yep.
All right.
And we've got, what other ones do we got there? Dgraph types. Okay.
All right.
I haven't played around with Rattle that much.
Yeah, I'm not sure I like this because what I kind of wanted to see was this one.
You want to see how the data related?
Yeah, I'm not sure this is giving
Go
me.
to we have the top, we have graph. Go to JSON and just see what's in that JSON response there. If you want to see.
Where I was just now.
That's okay. That's okay. We can go back to it.
Do it again.
So yeah, if you go over to JSON there, let's just see. Just want to see. This is returning the schema, and then
this is not what I want.
you were looking to see the data. You wanted to see the actual data.
I was hoping to see that relationship because what we now have here is an order, a customer, and some staff, right?
Yeah.
So let's go do something here. Let's go back and run a query.
I wonder, and maybe if you want to bring it up in another tab, Bill, if you right click and bring it up in another tab, Data Studio also allows you to visualize kind of how things are related too.
Well, let's just take a look.
That's what I use. So then I can see if you click on orders, you'll be able to actually see it go into orders, and then
Yes, this is what I was kind of.
No, so here's one of the things with GraphQL, right? Depending on how you want to traverse things, you know, you can pretty much infinitely go customer order, customer order, customer order.
This is what I wanted to see, right? Because
Okay.
we added the one order, bound the IDs of the customer and the staff to it.
Yep.
Now what we see here is from a customer, I can see all their orders.
Yep.
We're not duplicating data. I just remember when I was working with NoSQL, this was what I was missing, this relationship.
Yeah,
where-
because
Yeah.
you can change with a lot of the time when you work with a document-based database, you have this redundancy, you know, the normalization is extremely limited. I mean, I guess in as much as it can be, but you might have cascading changes where if you change something here, you're also going to need to change it here wherever you've duplicated that data for access. You don't really run into that with a graph database because
No,
you're
I had the relationships without the extra tables,
yeah.
right? And you saw from the schema that relationship between customer and orders were all done with these kind of, I don't know. It's like, I feel like I'm writing a lot less code. I can kind of visualize it. We do have to make sure we're setting right indexes here, but we always have to do that anyway.
Yeah.
Okay, so with the 8 minutes left, here's that user that I unfortunately, or customer I unfortunately created. So I know the ID, right? So what that now means is I should be able to do a mutation, delete a customer that has this ID, and it should go away.
That should work. Yeah.
All right, let's see. Says deleted. Let's go back to our data studio and it's gone. That's kind of cool.
Yeah.
Now, what would be okay, go on, Matt. What are you going to say?
And yeah, and just like SQL, you know, when we run an insert or an update, any type of read, update, delete, create, update, delete, it also brings back usually the number of rows affected. That's the same thing that's happening here with the num UIDs. That's the amount of affected nodes.
Okay, so I've only done it with IDs, but now that we have engineers on the line, oh, you know what it is? We don't have the right index probably for this, because when I was playing with upserts, which is the ability to, right, either do an insert if it's not there or do an update if it already exists, I needed to create a special index to be able to do upserts. And the index, oops, sorry, I keep bringing this up and it should be here. When I was doing the upserts, I had to add this hash index. So this hash index here allowed me to either do an insert or an update if that email already existed. If the name of the city already existed, then don't add a new city, right? Do an upsert. And this is what I kind of should have done. If we think about this for a second, we go back to my schema, right? I mean, ideally, people can have the same last name, but let's just say that they can't for a second, right? This would have allowed me to do that upsert. The only problem is I don't think this version of the database supports it because I don't remember seeing it again. Let's see, add customer. No, so we don't have the ability to there's a flag that becomes part of the query to do that. Anyway, this all triggered in my head the following as the last thing that we'll kind of do today. If I want to add an order, and I don't, maybe it doesn't make sense to do it. That's why I keep pausing.
What at the same time you create the order, create the customer as well? Is that what you're thinking?
So that we can do. I
Yeah.
know that we can create a customer and staff at the same time create order. I don't think it would make sense in this business model here, but
No.
I'm just wondering, can we, I guess we can. Can we link the customer not by ID, but by just last name? I guess we could here, right?
Yeah, I think you might be able
Let's
to.
try that. Let's try that.
Abhimanyu is going to say something. I
But
see.
like in that case, basically, the last name should be unique. If the last name is not unique, then I don't think we can link the
Right.
customer with just the last name.
Right. So
All
you'd
right.
have to use, could you use something similar to like some type of composite key where you'd be able to match on last name and email or something like that?
Uh, so we do not have composite keys yet. Uh, there's a plan to add those in the future. But right now, what we have is just the ID directive, which behaves as the unique keys, like which makes that only one field is unique
Okay.
within that
So,
type.
so we can only attach
Maybe
the,
if email is unique, then like we can link by email that
okay.
way.
Okay, cool.
I know this is going to fail, but I just wanted to give
You
it
gotta
back.
try it out anyways. The
So
date.
it
Yeah.
was-
Date,
Yeah, it's going to give it to me, right? And
Yeah,
I'll just
yeah.
substitute it.
copy and paste it in there.
So I'm going to try this time not to put the ID, but to use our names, since we know those are the only customers and staff in there. I know this is going to fail, so no big deal. I'm going to take, shoot, I'm missing it getting cut off. You know, before it gave it to me, oh, you know what? I'll steal this. Why not? I'll steal this.
There you go.
That I can't copy and paste it. Oh, there we go.
I think my prediction is, Bill, that it's going to create a new customer and new staff. That's even
You
though we've
think-
already,
Oh,
because they're not unique, right? Because you can have, because we don't have it as an identifier.
oh, you're right. This is going to create a new customer and staff with the same name because it's not built on any edge.
Yeah. Yeah.
Oh, so we can't do this. Okay, I'm so glad you said that. So,
But yeah, I mean, what I would do in this case is I would probably make, since the email is going to be unique, I'd probably use the email as the ID and then do it that way because it's much easier than that the generated identifier if you were
Right.
looking for ease.
the same way the upserts are working, where I've applied this hash here to make sure that the data is unique on this, we would need something similar.
Yeah. Yeah.
Other than that, we need the ID. Okay, which totally makes sense. And that's the other flexibility here, right? The flexibility is if I want to use what I call value semantics, let every order have its own kind of copy or something I can do that. Also, since that was new, we can at the time we're creating order, create the new customer and the staff. Again, I don't think that makes sense in this business model. Maybe we should just play with that one last time before we go here. Again, I don't think it makes sense in this business model, but let's add an order where the first name is, the customer is going to be Daniel. Last name,
My,
I still have that. That's good. The staff here is going to be, I don't know. This gets interesting. So then we go in our data explorer. We should see this. Okay, so it looks
So you
like
see-
that worked.
yeah, and num UIDs is 3. So we've got 3 new nodes created.
There it is.
Yeah.
There it is. The flexibility we have in creating these nodes based on the relationships kind of we created here is really, really nice. Because sometimes you're in different scenarios where we've got the order and everything, or we don't. And I don't know. I just love the flexibility in this.
Yeah. Yeah. And one last note here, Bill. When we were trying out the not data studio, when we were trying out Rattle earlier, we should run a query, and then that will allow us to pull up. You can run a query, and that query. So if you wanted to run one of those retrieval queries that you ran before, those to grab all the customers, or you could grab all the orders or whatever. You could do just get order, or for a customer, and grab the,
Right, that's the order.
Yeah.
Send orders. So if I wanted the customer and all their orders, I can ask for the first name, the ID, the last name.
and then you could do date, ID, and status, and it would grab those for each and every single order that's there.
Okay, so there's our data.
Yeah,
So you're
and
saying I can take this.
take that query, and run that within Rattle. Yeah. So if you actually go back, yep, exactly.
Do I just pop that in here?
I believe so. Let's try it out and see. And then do run on the top there.
Didn't like me.
Left
Maybe
round brackets.
maybe I don't need that. No.
No, someone else got some input for us.
What am I doing wrong here?
What are we doing wrong here?
Maybe this can't run
This
graph.
is a GraphQL query.
This
It can only do DQL, and I
It's
don't
gotta be
know
DQL. Okay, it's gotta be DQL.
how
Okay.
to make that happen. So there had to be a small conversion there. So I ain't gonna make that happen. Anyway, I love the idea, Matt. We just have to learn how to. Maybe we need to build a conversion tool for some
Yeah.
basic GraphQL to.
Yep.
Okay, so
We're at time right now, Bill. So I'm not sure if we want to wrap up quickly and kind of give our final thoughts.
I do. I'm trying to bring this back up. Okay,
Sure.
stop the share. So I think we did pretty good, dude, in 1 hour. I think we saw some basic SQL relationships get modeled here in GraphQL. And I think it proved to me one more time how much more flexible the database is and the querying system is, and just more efficient. I always
Yes.
feel like it's so much more efficient to do things this way than the traditional SQL.
Yes, agreed. Agreed. If one argument usually with NoSQL as well, it's really tough for us to enforce relationships in it. This is a way to kind of bypass that argument and still give you the flexibility that you're going to see with those other, you can definitely do things within that graph database that you could keep it very similar to document based if you wanted to, but why would you do that when you can enforce these relationships, right within the data?
And the majority of the relationships that we need are what we did today, which is those 3 tables, right? Like
Yeah.
I showed the hash for the upserts, which we can't just do yet. We're waiting for the cloud environment to get that functionality. But
the most important one that we used today was, I think, the has inverse. Allows you to create that relationship, right?
yeah. And I'm glad we struggled, and I'm glad it wasn't obvious, and I'm glad we had to look some stuff up. I'm glad we had the engineers, because sometimes when you see people giving talks on this stuff, they make it look like easy, and you go to your desk and you're like pulling your hair out. This stuff isn't necessarily obvious either. It takes time. It took me months to figure out how that syntax relates to the relationships and the queries. But the tooling is so cool. Tooling is so cool. It really is. I wish I had that 6 months ago when I was first learning myself. All right.
Agreed.
I don't know if anybody else has any other questions. I hope you feel like there was some value in seeing us do this today. I know I always get something out of it, but that's it. Our hour's up. So we'll figure out what we're going to do. Nothing in July. July, I'm taking the month off. I need some time. But in August, we'll figure out what we're going to do next from the usability aspects of working with Dgraph.
Awesome. Thanks again, Bill. As always, great to spend an hour with you and play around with Dgraph.
All right.
Well, thanks again, everybody, for joining. And we will see everybody again with Bill in August.
Yep.
Take care, everybody.
Can we stop this, or there's no stopping?
We'll figure.